So this is a presentation of our clean room garment redesign by Keenan Darkins, Carl Lenhart, Michael Jordan, and Andrew Yates. So the first problem we identified were tears at the seams. One of the largest complaints was the frequency of tears that caused contamination when working with hand tools or getting caught on instrumentation. And the only way for the worker to identify tears through their own inspection or inspection by a peer. And this poses a contamination hazard and reduces the worker's efficiency due to time spent checking for tears. So our solution is wired seams. The area around the seams will be made of a mesh material that sends power once per minute, just like a pulse. And if the circuit doesn't complete, the suit will detect the tear and prevent contamination. And a waterproof device will be built into the wrist of the garment. So this is our example solution.
Here's a simple representation of a wired seam system. Several circuits would be wired through various limbs. If a tear occurs, the user can quickly identify which part of their suit is damaged. A green light indicates a suit in good condition. Red lights indicate tears.
Okay, so here's the implementation of this. Since the microcontroller is simply stitched in the material, the component can be easily upgraded over time as new needs arise. And washing the suits won't pose a risk. The microcontroller, it's going to be waterproofed. And in case of any malfunctions, it's a very simple system, so it can be easily replaced. And standard suits can just have wire along the seams, but highly sensitive clean rooms can be stitched with wire mesh all throughout the fabric rather than solely at the seams. So for example, the Gore-Tex suits. The second problem we identified was that boot covers slide down. So when we're wearing the current boot covers, it's common for them to slip down, requiring users to stop work and pull them up. And this is due to the poor drawstring holder that does not provide a snug fit. And the downward laminar airflow in the clean room also just fills them with air and forces them to slide down. And this creates hazards, can cause snags or falls and tears. So this is our proposed solution.
Oh no, my boots are falling down.
The user will select from a range of sizes from small to double XL. First, they will zip in the lower boot part to the upper pant leg. Once fully zipped, they will cinch it together to tighten it and reduce billowing. This will eliminate the problem of the boot cover coming down due to only having one method of securing it with the elastic loop.
So the pants will have multiple vertical layers of the zippers to ensure that they can be adjusted for different heights and increased accessibility. The zippers will be secured in place before you enter the clean room, so it'll be unlikely that a worker will have to attempt to re-zip before putting on the restrictive gloves. Users won't need to bother with buttons or hard open clasps within the clean room. The third problem we identified is when talking to coworkers, the user voice gets muffled. And it's human instinct to pull down the mask, which can cause contamination. There's a lot of particulate that comes out of the mouth. So our solution is a clear face mask with filtered vents on either side, allowing for visibility of the mouth while ensuring breathability of the user and audibility of speech. And at the nose will be a metal nose clamp piece, allowing for a tight grip and reducing fog on the glasses and the goggles. And this new face mask will be connected with the hood, and users will be more likely to keep their mouth cover in position for the whole shift, and the tighter seal will reduce particulate. So this is our final prototype. It was decided to, we fixed the big three problems that were pointed out the most by the fab workers. And this is only a concept solution because we don't have materials to actually construct. But the added wires in our microcontroller system won't be expensive to implement for disposable suits because the wires only have to be connected to the suit, and battery packs can be manufactured to provide power to the wires. And a zipper connecting the boots to the pants will make it so the boots won't fall down, and the proposable design will also solve the issue of the contamination from users pulling down their face masks to communicate. And this will require a simple hood redesign.